We have a triangle, and these are vertices in a two-dimensional plane, and we try to find the area of this triangle. Now here I didn't show the coordinate system, right? It's rather easy to imagine that this is x-axis and this is y-axis, where I don't have to show it. Now we just found area by using definite integration. Okay, so first of all, we must find the equation of those straight lines. Okay, now how to find the equation of this line passing through these 2 points? We can use a 2-point form, right? Which is y minus 3 over x minus 3 becomes plus 3 is equal to, and 1 minus 3, right? And x minus this becomes 7. So this means y minus 3, x plus 3 is equal to minus 2 over 7. Then we can find y as y is minus 2 sevenths, x plus 15 over 7. Or we can express x in terms of y, so that is equal to 7 over 2 y plus 15 over 2. Okay, so we can find a relation between x and a y for this straight line in 2 ways, because we are going to integrate two ways, two methods, 2 ways of integral. So we need 2 functions. Now let me write these functions. Okay, this is a y is equal to negative 2 over 7x plus 15 over 7. And similarly, now okay, write this one is a different color. Or we can write x is equal to minus 7 over 2 y plus 15 over 2. Okay, so in other words, I can express this line as equation y in terms of x or x in terms of y. Now similarly, we can find the other lines, and let me skip the process, but rather show the result. This is 2x minus 3. This one is y is equal to 2x minus 7, or x is equal to y over 2 plus 7 over 2. This is x is equal to minus y over 2 minus 3 halves. Well, okay, I just save time, to skip these process of finding these functions, which is not difficult. It's rather easy. Now, the main job is to start how to set up the integral to calculate the area. Okay, I think I maybe add this coordinate system. This is axis. This is the y-axis. It's really for the line is not very straight, but rather okay. Imagine this is a straight line. All right, now we we want to find an area, and we choose the variable, and that is the most important. Say, for example, we choose x as my independent variable. Then this line is this equation, right? Y is a dependent variable, x is an independent variable. So is this, and that, and so on. Now, if I want to find area using x as an independent variable, that means I'm choosing, choosing a very small slice. The width is a dx. See, that's the width. The width is a dx. The length is this y, y1, say, minus that y, y2. y1 and y2 are a function of x. In that case, that x is an independent variable, and we are integrated with respect to x. Okay, that means we integrate this y minus this y, which is minus 7th x plus 15 over 7 minus this, right? This is minus 2x minus 3. Yeah, dx. So that this minus this one, this is the length, times dx is the area of this slice. And the summation means summation. Integral, this s is a integral sign is actually a summation, sigma. And this integral is from minus 3 to 1. From minus 3 to 1. And then add this kind of slices. The width is dx. The length is from this y minus that y. See? So this one is equal to integral this minus 7th yx plus 15 7th minus this y, see, 2x minus 7 and the dx, and it is from 1 to 4, from 1 to 4. Okay, and then you integrate. These integrals not difficult, maybe a little tedious, and we find the result is 24. Okay, so I skipped all the details in calculations, which is not difficult but rather tedious. Now, if we do the different, if we do the slices like this. So the width is a dy. So we choose y as an independent variable, and we are integrated with respect to y. Okay. Then from this point is which is a negative 5 to this point, which is y equal to 1. Then you have another kind of slices. This is also dy. Then y from this function to this function is changes functions. So the area is rather from minus 5 to 1, and from minus y to this one, from this x minus that x. This x is 2y over 2 plus 7 over y minus this one, minus negative y over 2 minus 3 halves dy from minus 5 to 1, and then add this triangle, this piece is from 1 to 3, and this function, which is this one, minus 7 over 2y plus 15 over 2 minus this function, which is negative y over 2 minus 3 halves, and a dy. Then I through the calculations, which is not difficult, rather a little tedious, is equal to 24. Okay, you may calculate the details, to verify that the area could be found through different integrals. You get the same result. Okay, this is the integral with respect to x, and this is the integral with respect to y. And we are analyzing same picture, which is the same area. And this is a very good example that you can thoroughly train the application of a definite integral as a finding area. Okay. Thank you for your watching.